Hello, welcome to 8.1, the chapter of radicals. So radicals is this root sign. And as I have been harping the whole time, there's an implied, we often, when we just see the single root sign with no number here, we call that a square root. But really, it is a radical sign. And we are, because it's the most common one, we do not put the implied 2 there. I'm going to suggest you sort of write in the 2 on your own paper, because then interpreting it, when we want to interpret its fractional power, it kind of makes sense because it's 2. And we have to pull out pairs. We also have the radical with a 3 here. And that is called a cube root, or sometimes a third root. We have the radical 4 root, and that we call the 4th root. And if there's a 5 there, we call it a 5th root. If there was a 6, it would be the 6th root. When we get to these later ones, the 5th root, the 4th root, it kind of makes more sense, the exponential interpretation, because this 4th root, or this 4th radical, is the thing inside raised to the 1/4 power. This 3rd radical is raised to the 1/3 power. And the 5th radical would be this thing raised to the 5th power. So, but what does the radical mean? So it kind of makes sense what it means when we think of what its fractional power is. So inside we have 2 times 2. 2 times 2 happens to be 2 to the 2nd power. And if we look at this, 2 to the 2nd power to the 1/2, well, we know we multiply exponents, so this becomes 2 to the 2 times 1/2, and that just equals 2 to the 1. So in essence, this 1/2 undoes the raising of the power 2. So when we're doing square roots, you're asking yourself what number multiplied by itself. And so we only need one of them out. So you have to sort of circle both of them, pull 1, 2 out, and then cross both of them out. When we're looking for a third root, we're looking for 3 tuples. So we need 1, 2, 3. We're like asking ourselves what number multiplied by itself 3 times. So inside here, this is an 8. 8 happens to be 2 cubed. So if we want the cube root of 8, we're asking what number multiplied by itself 3 times is 8, and that has to be 2 times 2 times 2. So here, when we're doing a cube root, we're looking for groups of 3. And when we have a group of 3, we pull all of them out, and we only pull out, all 3 of them become just the 2. In the 4th, we're looking for 1, 2, 3, 4. So we're looking for groups of 4. Pull them all out, and we bring in 1, 2. For the 5th root, groups of 5. 1, 2, 3, 4, 5. So pull out all 5. Cross them out, but you only pull out, the 5th root of 2 to the 5th is 2. So over here, we have 5 2's to the 1/5. That's 2 to the 5th. All raised to the 1/5, and we get that's 2 to the 5 times 1. Oh, that should be 1/2. 1/5. And then, all right, let me go I realize I made some boo-boos there. And I will correct those to the 1/3, to the 1/4, to the 1/5. There we go. Now my fractions are going good. So those are basically what radicals are. There's 2 approaches. The first thing we're going to have to do, I want to highlight, is back to prime factorization. That's kind of our first step, going to be doing prime factorization. And then there's 2 approaches. You can look for the pairs, triples, quadruples, and pull out, like the way I was showing there, or you can convert to the fractional powers and distribute the fractional powers. The later problems in 8.1 homework, it's going to be easier to do method 2, and in the earlier one, it's, you actually get to practice both methods potentially. So when you just see a square root, I want you to add in the 2. I want you to add in this implied 2. So 36 happens to be 6 times 6. So I'm rewriting it as 6 times 6. I have a pair of 6s, and I'm bringing them out and pulling out a 6. Another way to look at, if I want to do pure prime factorization, 36 is 4 times 9. 4 times 9. 4 is 2 squared. 9 is 3 squared. So I can write the square root of 36 as square root of 2 squared, 3 squared. And I'm going to convert this to its fractional powers. And so I have now 2 squared, 3 squared, all raised to the 1/2. I distribute the 1/2. I have 2 to the 2 to the 1/2 times 2, 3 to the 2 times 1/2. So I basically have 2 times 3 to 6. In this case, going to the power method it makes it longer, but later on you'll see that it actually makes it quicker. 125 is 5 cubed. So I'm looking for the third root of 5 cubed. And what you're asking yourself is what number multiplied by itself 3 times, and we want to undo that. So you can sort of see right here, it's going to be 5. But I have 5 cubed to the 1/3, and that equals 5, and 3 times 1/3, which is 5 to the 1. The other method we could go about is saying we need the cube root of 5 times 5 times 5. So instead of writing 5 cubed, I'm going to write 5 times 5 times 5. And then I see 3, so I need 3 tuples. 1, 2, 3. Circle them all out. Where did my circle go? And then pull it out. So I have a 5, and so I get 5. 216 is 8 times 27, and 8 is 2 cubed, 27 is 3 cubed. So going to the power version, I'm replacing 216 with 2 cubed times 3 cubed, and I'm raising it to the, since this is a 3, 1/3 power. And then I distribute the 1/3, and you don't have to do this step. I mean, you can sort of know that 3 times 1/3 is 1, 3 times 1/3 is 1, and you can just kind of start skipping. And then the other way is you can write it, instead of 2 cubed, you do the 2 times 2 times 2, and the 3 cubed is 3 times 3 times 3. We're looking for groups of 3, and you pull out the 2, and groups of 3, pull out the 3, and we're left with 2 times 3. This next one, we have the cube root of 1,728. That number happens to be 8 times 216. So I have a 2 cubed here, and I have another 2 cubed. So in essence, I have 2 to the 6, 3 cubed. And here, when I multiply 2 to the 6 by 1/3, I get 2. And 3 times 1/3 is still 1. So now I have 2 squared times 3. 2 squared happens to be 4 times 3, and I get 12. If you wrote them all out, 6 of these 2's and 3 of the 3's, I pull this set of 2's pulls out a 2, this set of 2's pulls out a 2, and this set of 3's pulls out a 3. This next page here, I'll add this into the thing. It's just a fact sheet. So over here, I have the prime factorization of the numbers up to 99. So, see, I've given you a head start. And sometimes if you have bigger numbers, like if you had the number 244, if you had the number 244, well, you can see that it's divisible by 4. So 4 goes in the 24 6 times, and so we get 4 times 61. And then you can come over here and find 61. Oh, it's prime. So this is 2 squared times 61 to the 1. And that's, so having the first 100 numbers, you can kind of, when you have bigger numbers, you can get to what its prime factorization is. The other table I have here, well, I have 3 of them. The first one are the powers of 2. So, 2 to the 0, 2 to the 1, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 64. I went up to 2 to the 13th. So far in the homework, I've only seen up to 4,096. But notice I'm saying prime factorization. Turns out you can then do a prime factorization in the power. So 4 happens to be 2 times 2. So 2 to the 4th is also 2 squared, which is 4. 2 squared is 4, so that's 4 squared. The next one, 6, that is a multiple of, 2 times 3. So we can, 2 to the 6th can be 2 squared raised to the 3rd power, so that's 4 to the 3rd. Or we can get 6 by going 3 times 2, so it's also equal to 2 cubed raised to the square power, which is 8 squared. So 64 is 2 to the 6th, 4 to the 3rd, or 8 squared. So it has multiple interpretations. 2 to the 256 is 2 to the 8th, and that can be 2 squared to the 4th power, so 4 to the 4th, or it can be 2 to the 4th squared, so that gives us 16 squared. 2 to the 9th, so 512 is 2 to the 9th. 9 is only 3 times 3, so we just have this 2 to the 3rd, so we get 8 to the 3rd. We have a couple interpretations of 2 to the 10th, because 10 is 5 times 2, so we can be 2 squared to the 5th, because that gets us a 2 times 5, which is 4 to the 5th. But we can also go 2 to the 5th squared. And so that's 32 squared. 2 to the 11th, 11's prime. 12 has 2 times 6, 3 times 4, 4 times 3, and the last one over here is also 6 times 2. So we have a couple different tips. So 2 to the 6, if we go 2 squared to the 6, we get 4 to the 6. If we do 2 cubed to the 4th, we have 8 to the 4th. If we do 2 to the 4th cubed, we have 16 cubed. And the last one, if we have 2 to the 6 squared, is 64 squared. So, we're prime factoring, and then there's even more prime factoring. I also have included the 3 table, and similar 3 to the 4th, which is 81, can also be 3 squared, so that is 9 squared. 3 to the 6th can be 3 squared cubed, so that's 9 cubed is this 729. Or it's 3 cubed squared, so that's 27. Oop, I'm missing. I'm missing the square there. There we go, square. Good thing I'm doing my lecture before I post the notes. 3 to the 7th, 7's prime. 3 to the 8th, we've got a couple alternate definitions. I haven't seen any of these numbers in the homeworks yet, so you may not need them, but I figured I'd just post them up there. And the last one you might need are some of the powers of 5. The most common that are used are up to 5 to the 4th power. And then one thing that's kind of neat to see when I was doing this, once we get to here, we have 125, 625, and then we get a 125 again, 625, 125. So I imagine if we looked at 5 to the 8th power, we'd get a 625. Stuff here, I don't know what that is, but the last 3 numbers keep repeating back and forth. So this is just a little fact sheet I'll post up to you guys. The last thing in 8.1 is like learning how to use the calculator. I'm going to make this bigger. Yeah, we'll make this bigger. Okay. So the keys we'll be using are the square root key, which is, so here's the square key. Now the square root undoes the square. And what's kind of nice is a lot of these functions that are what are called inverse functions, they're always the second function associated with the key. So if you have something that's squared and you need to undo it, well, look right above it. That's how we undo it. So to get the square root symbol, we have to hit second and then x squared. And then we type in the number. Like over here, I had done second x squared 1, 6, enter. And then I get the answer 4. With the 32, I went second square, and then it's showing me the square root sign, 32, and I press enter, and it gives me the answer of 4 square root 2. So when you're in math print mode, which lets us do a lot of this thing, it's going to, with just square roots, so remember there's an implied 2 here, with just square roots, it will give you this reduction here, where you still know what's inside. When we get to higher roots, it'll give you the decimal approximation. So in order to get a cube root, or a fourth root, or a fifth root, the key here we're looking at is this x square root. So that little x there lets you know that I need to put a number there first. So I would put in what root I need, then second, and then this guy, and that will give me this 3 square root, and then I can type in my number 8, and I'll get the answer 2. So when we want to do a multiple root, you look here, there's the x, so you're like, okay, I need to say which root. Like, so if I need a fifth root, I would do 5, second, this guy, and then I would type like 32, and the fifth root of 32, the answer would have gotten 2 there. The other way you can also type in is using fractional power. So remember, we have the third root of 8 is equal to 3, second, the chevron key 8 and enter. But third root of 8 is also 8 to the 1/3. So how can you do that? You can do 8 and just do the chevron, and then I would do parentheses, and how do you get 1/3? 1. I wanted to just check to see if it works the other way too. If I do 8 raised to the fraction 1/3. Okay, you can also, I just checked on my calculator, we can also go 8 to the 1/3 can be 8 raised to the, and then you use your fraction key, 1, and then I had to use my arrow down, 3, and then I did a right arrow and then enter. So, and this displays 8 to the 1/3. So that's the display. And this guy would look like 8 parentheses 1 divided by 3 parentheses equals. And it will equal 2. So that's some extra calculator stuff. And I've already gone over the homework.